Stop scrolling. You think the Black Sea is always black, right? Well, that's a myth. Every single summer, this massive body of water transforms into an impossible shade of electric turquoise, glowing brighter than any ocean on Earth. We're going to uncover the incredible biological secret behind this phenomenon and why scientists are using it as a critical early warning system for climate change. This isn't just pretty art. It's nature's most visible dashboard for our planet's health. Here is the first thing you need to know. The Black Sea does not naturally turn turquoise. In fact, its name comes from a very different story entirely. For thousands of years, sailors have called it the Black Sea because, under normal conditions, it is dark and murky. It sits in a unique geological trap between Europe and Asia, connected to the Mediterranean by only a narrow strait that acts like a one-way valve for water flow. Freshwater from rivers rushes into the sea during spring, but once summer hits, that freshwater slows down and the deep, salty water rises up from below. This creates two distinct layers, a dark, dense bottom layer and a lighter surface layer. The darkness you see in winter is real. The water absorbs almost all light because of high concentrations of dissolved minerals and a lack of sunlight penetration to the depths. But then comes the showman. Every year, starting around late spring or early summer, something magical happens. Massive clouds of microscopic creatures begin their ascent. These are coccolithophores. You cannot see them with the naked eye. They look like invisible dust motes floating in a beam of sunlight. However, when they bloom in such staggering numbers that they cover hundreds of square kilometers of the ocean's surface, they change everything. Their shells are made of calcium carbonate, which is incredibly reflective. When these microscopic plates scatter sunlight, it bounces back to your eyes with an intensity that no other body of water can match. What looks like a sudden, violent shift from black to turquoise is actually a bloom reaching its peak density, turning the entire surface into a giant mirror, reflecting the summer sun off calcium plates that would otherwise remain invisible in the deep, dark waters below. Let's talk about these coccolithophores for a moment, because they are the true stars of this show. These tiny organisms are not fish, nor are they plants or animals. They belong to a group called phytoplankton and are essentially single-celled algae with a very specific superpower: photosynthesis. They drift near the surface where sunlight is abundant, absorbing carbon dioxide and releasing oxygen, just like trees do on land but in the middle of the ocean. But what makes them unique, and what creates that stunning visual, is their armor. Each coccolithophore is encased in a delicate shell made of microscopic scales called coccoliths. These scales are not organic. They are mineralized calcium carbonate, much like coral or chalk. When these creatures multiply rapidly during the nutrient-rich summer months, they form what scientists call coccolithophore blooms. Imagine billions upon billions of tiny mirrors aligned perfectly across a vast expanse of water. The sheer density of these plates is what causes the optical illusion we see from above and even from the shore. They reflect sunlight in a way that creates that vibrant, almost neon blue-green hue. It is a biological artwork on an industrial scale. This bloom doesn't just happen randomly. It requires specific conditions: warm temperatures, plenty of nutrients washed down from rivers like the Danube or Dnieper, and enough sunlight to fuel their rapid reproduction. When these elements align, nature unleashes its brightest display. The fact that this happens every year with such consistency speaks to the stability of our oceans, but also hints at how sensitive these ecosystems are to changing weather patterns. Now, while the turquoise look is breathtaking, it's not just a party trick. It serves as one of nature's most important warning lights. Scientists have been monitoring these blooms closely because they act as a barometer for ocean health and climate stability. The reason this bloom matters so much to researchers like Norman Courting at NASA is that coccolithophores are incredibly sensitive to environmental shifts. Their ability to form massive, bright blooms depends heavily on the balance of carbon dioxide levels in the atmosphere and the temperature of the water column. There have been years when these blooms were weaker or less vibrant than usual, and scientists have linked those periods to broader changes in ocean chemistry. If the bloom is particularly strong this year, as it was recently noted compared to previous decades, it can indicate a specific type of climate interaction where the ocean is absorbing carbon, but also reacting with intense biological feedback loops. It's a complex dance between the atmosphere and the deep sea. When the bloom is massive, it means the surface water is warm enough and nutrient-rich enough to support this explosion of life, which in turn helps remove carbon from the air through photosynthesis. However, if climate change causes the stratification of the water layers to become too extreme or temperatures to spike unpredictably, these blooms could shrink, potentially reducing the ocean's ability to act as a carbon sink. So, when you see that glowing turquoise ribbon stretching across the Black Sea, don't just think it's pretty art for Instagram stories. Think of it as nature's real-time health checkup. It tells us whether our oceans are thriving or struggling under the weight of global warming. The intensity and timing of these blooms provide data points that satellites can track over decades, giving us a clearer picture of how our planet's climate is evolving in real time. So, what should you take away from this? First, never judge a book by its cover, or a sea by its name again. The Black Sea proves that appearances can be utterly deceiving, and that beauty often hides the most complex biological machinery right under your nose. Second, understand that this visual spectacle is a direct result of microscopic life fighting for survival, while also helping to regulate our global climate. These tiny creatures are doing heavy lifting in maintaining the balance of our atmosphere. Third, pay attention to when these blooms happen and how intense they get. Changes in their size or timing are early indicators of larger shifts happening beneath the waves. By watching the turquoise glow, we can better predict changes in ocean temperatures and carbon levels that might affect weather patterns far away on land. It's a reminder that even in places that seem distant or misunderstood, like the Black Sea, nature is constantly adapting and communicating. Next time you look at a map of Europe and see that dark label for the Black Sea, remember to imagine the vibrant turquoise surface bubbling up every summer. It's a visual testament to the intricate connection between tiny organisms and our entire planetary system. If you found this as fascinating as I did, hit that subscribe button so we can dive deeper into these incredible ocean secrets in future videos. Drop a comment below telling me, have you ever seen a similar color change in your local waters? Let's discuss how nature keeps surprising us every single day.